Welcome. Today we're going to be talking about this book, which is Model-Based Systems Engineering with OPM and SysML. This is a book by Professor Dov Dori of the Israeli Institute of Technology, Technion. It's a very good book written in 2016, especially for people who are interested in OPM, Object Process Methodology, SysML, and model-based systems engineering in general. It's different than the Professor Dori's other book, which is Object Process Methodology, a Holistic Systems Paradigm, which came out in 2001, 2002 sort of time. 2002, this book was purely discussing and introducing object process methodology, whereas the new one incorporates SysML, which of course is very popular in the industry, and so it's important that when talking about the topic of model-based systems engineering, that of course it's difficult to ignore SysML. Okay, so we're going to be going through the book and discussing various topics that are up there. And just before we start, I do have a spare copy of model-based systems engineering with OPM and SysML. And if you would like the chance to have it, I will send it to you. There's just we'll hold a little competition. So the best comment on the YouTube video will get it. The best, and that could be a question or an idea or how you've been using model-based systems engineering, anything at all. So if you'd like to be eligible to have the copy, I just need you to subscribe to the YouTube channel, leave a comment, and you could leave as many comments as you want to increase the likelihood that you might leave the one that I think is best, and subscribe to the newsletter. And those free things will be written there in the instructions, and kind of come October time, I'll pick which comment I think was the best one, and I'll send it to you. So that's good. Okay, so let's just look over my notes. Oh yeah, and the other thing with the newsletter, if you sign up to the newsletter in general, I'll send you my my PDF of notes that I made when creating the video. So this video is sort of divided up into different questions that the book sort of answers, and that will then give you a good overview, and you will delve into the book yourself, which I would encourage you to, because of course OPM, like SysML, like the many other model-based systems engineering languages, is very diagram focused, and therefore you really need to get the book to get the full value of all those different diagrams and learn it for yourself. But what is the so question one, what is the central idea or argument of this book, and why does it matter? So the book presents OPM, Object Process Methodology, as a comprehensive and integrated language for model-based systems engineering. The key idea or difference of OPM compared to some of the other languages, in particular SysML, is that there is there's one diagram type, and that diagram type is used to describe the behavior and the structure of the system. Whereas those of you who know SysML will know that there's 9 different diagram types, and each of those diagram types describes a different aspect of the system, whereas with OPM you have one diagram type, and then you can have multiple diagrams to increase the level of detail of your system. And the benefit of that single diagram type is that it's simpler to understand. There's less symbols, and it's likely less intimidating to be understood by stakeholders who are less familiar with model-based systems engineering and other similar topics. Plus, the other benefit of OPM is that there is a text-based language that accompanies every single diagram. in every diagram element. So you can read a OPM diagram with its OPL, its accompanying object process language, and there is one-to-one correspondence between the content contained within both, and this can be very helpful for people who are less familiar with all of the various different symbols that are contained in a OPM diagram, an OPD, object process diagram. And this is again different than SysML. SysML in the formal specification doesn't have such an accompanying language. All right, so how is the book organized and how should you read it? So let's take a little look at the table of contents here. And there are three big sections in the book. So we've got part one, model-based systems engineering introduced. Part two, the foundations of OPM and SysML. And then part three, structure and behavior diving in. So that part one is, I think, so let's think of yourself, and you can categorize yourself into, let's say, one of four different categories. So you might be a person who's never used or seen OPM before, SysML before. So you're let's say a novice to model-based systems engineering languages. And if you're that person, then the first half of part one would be very helpful to go through, and then have a go at using OPM as a language and potentially SysML as a language using a tool out there. The book talks about OPCAT, which is the tool that's been developed with Professor Dov Dori's research team, but of course there's OP Cloud, which is another one that has been developed with Professor Dov Dori's involvement. So if you're that novice to this world, I'd say the first half of part one, or maybe the whole of part one, is a good place to start. But I would be a little cautious of going through everything unless you were very determined to become an expert of model-based systems engineering immediately. But even then, I'd say you probably want to go and have some practice, because there is quite a lot of detail towards the back, which might be a bit of a hindrance to start with. I'd say if you've used SysML before, but you're new to OPM, then you could go straight through part one and into part two, because I think you'd have a lot of the concepts around objects and how to model a system diagrammatically already. If you've used OPM before but not extensively, again, I think part one and part two would be good. You'd get into some more detail, and you likely would come across ideas that you had tried to model before, you thought would be useful to model before, but hadn't quite got the right syntax there from you're less experienced in OPM. And then finally, if you've used OPM extensively, I think you can dip around the book for particular areas where you're like, I'm trying to do this, but I can't quite remember how, I don't know how. The book does have a lot of detail, especially on, see this is right at the back in part three, where you've got all these XOR and OR logical like logic gates, but how do you model those in OPM? And you can do that here. It shows that all there very well. But then again, you can just read the whole thing through as a refresher. I mean, that's what I did when it came out. I'd already I taught myself OPM a long time ago using the original book, which is good. Is good, and I think if you're already familiar with OPM to quite an extensive level, there's a lot of value in just going through the whole thing, because this was written, of course, after the publication of the ISO standard, so you can really get the full details there. Okay, so that's how the book's organized. So let's now delve into the actual topics. So what is model-based systems engineering, or MBSE as the acronym is? Well, it's a formalized approach to do systems engineering using models to support the design, analysis, verification, and validation throughout the systems lifecycle. And it focuses on a model-based approach as opposed to a document-based approach. So what I'm holding in my hand, my notes here, this is all natural language and it's a bunch of bullet points. This would be considered sort of a document as opposed to a model, which is a formalized thing using discrete set of symbols, often in these diagrams, which can formalize the definition of a system. But what model-based systems engineering isn't is a single sort of tool or language or software application. It will likely encompass several of those things, maybe often sort of combined together, but it isn't a single one. So you wouldn't say, my model-based systems engineering is my OPM and my OPM tool, or my SysML and my SysML tool. It's a wider concept than that. And now, foundationally, often to a model-based systems engineering approach will be conceptual modeling, and we'll dive into that as a separate topic as to what that is. But it's the foundational aspect that guides the system development, and is likely the description of the system at a very initial level before those details are filled in with the more advanced descriptions and details that are necessary to bring the design into fruition. Now, model-based systems engineering is likely, and often through necessity, a unified approach across all disciplines. So if we think of, say, an autonomous flying drone, this, which is powered by batteries, this is going to require electrical engineering to describe the motors and the battery. It's going to require people with knowledge of aviation and avionics and control systems and the fluid dynamics, but also the communication systems, the wider environment, the purpose and the task of the drone, the operators. So it's really cutting across many disciplines, and therefore for a successful MBSE approach, we need to be able to combine those things together in a unified model, such that we can move our system to fruition and have it providing benefits to its customer. To use MBSE tools, they either need through multiple to cover all those different disciplines, or one that can cover them all. And then we often have tools to improve the efficiency of applying MBSE. So Magic Draw is an example for often used for SysML, UML, and things like OpCat and OP Cloud are used for OPM. Okay, so what is conceptual modeling? So this is a formal process of creating models that represent real-world entities and their relationships in one-to-one correspondence. So an example that I've written down here would be of a hospital system, which would include entities like the patients, the doctors, the other medical staff, maybe a medical record. That could be a piece of data that the doctor is referring to, and also editing, updating based on his consultations, testing of the patient, treatment, and that could be broken down then into individual medicines that he's providing, but also these treatments that are done by machines, like radiation therapies, things like this. But what conceptual modeling and stress modeling is just a sketch or an informal diagram. To be a model, we need to use a formalized diagram where the symbols have meanings. And OPM and SysML are examples which have that. So I'll just pick a random page here out the book. Yes, I mean here, this is page 140. So it's showing some examples of some SysML diagrams here. Is this activity diagram? Yeah, activity diagrams. That's a way of describing behaviors in SysML. whereas pick another random page with a diagram on it. Yeah, here's page 179. So this is showing, we see here, might be a little hard to see. This is some OPM here showing some structure and behaviors of an engine, and yeah, just quickly showing you how these symbols, these special symbols, have actual meaning, and that's necessary for conceptual modeling. And in science, this book isn't just about modeling engineering systems that we're actively creating. It can be about describing things that exist. And so for if you're conducting science and you need to describe natural phenomena, you can use conceptual modeling to describe things formally, such as in the book it shows the life span and journey of a frog from being an egg in the pond to becoming a tadpole to then becoming a frog, an adult frog. But also we can then use it in engineering to describe things that we're actively creating. So those descriptions of nature are describing what is, and with engineering we're often describing what are we going to create. And that conceptual model can then be a blueprint for further modeling. So like I showed you with that example a moment ago with an engine, that wouldn't be sufficient to create the engine, but it shows at a high level what it is and likely how it's embedded within other systems, such that that big picture can be described, and then the detail can be filled in potentially with other tools, likely with other tools. Okay, and we've spoken about how it can be a common framework across disciplines. And now what's also likely key is it facilitates communication and understanding. So clearly, for an extensive project, one individual is never going to be able to hold the whole project in their mind, but these less detailed views that show the important aspects of the system, be it the behavior or the structure or the benefits that are derived, can then be consumed by multiple stakeholders who can provide feedback, and it can be iterate the system to one that is beneficial in an engineering sense, or if it's in a science sense where we're more in the discovery mode, that sort of feedback in how we can update our model that best describes what nature is showing to us. But what conceptual modeling isn't is a sort of technical document that shows the full specification of the system. So it's taking the complex ideas and showing what's poignant around them and what's important, but all of the detail is not possible to be contained within the conceptual diagram, and actually that's a hindrance. Okay, so what is OPM and what is SysML? Because those are both on the key title of the book. So they're both examples of conceptual modeling languages. Things will get a bit confusing because OPM, object process methodology, technically speaking, is a methodology for creating conceptual modeling languages. OPM, object process methodology, is a methodology for creating a conceptual model using object process diagrams and object process language, which together are a language. So this can get a little confusing, but essentially every single object process diagram has a corresponding language, and tools typically will generate both at the same time. SysML is another such one of these languages that we can use for conceptual modeling and as part of our model-based systems engineering approach. But let's just think of both of these things as languages, much like French is a language, English is a language. And so we can describe either engineering systems or natural phenomena using these languages. But the benefits if we use OPM or SysML is that we have a formalized one with formalized symbols that really make it very easy to avoid miscommunications that are often associated with natural languages. Okay, now a very key idea that I touched on right at the beginning of the video is, so what are the core building blocks of OPM and what makes it so special? So that first one is that there's only one diagram type, and I don't say only like it's a negative. I mean it means that the person who's coming to understand OPM, they have to first of all understand the language before they can understand your particular diagram, but they only need to learn one diagram type, as opposed to SysML where there are 9 different diagram types. And on those diagrams, that singular diagram that OPM provides us, there are simply things and there are links between things. And a thing can be either an object or a process. So object-process methodology, objects and processes. And those objects and processes can be connected together with links. So let's think of what those objects could be for a simple example. So let's just think of making a cup of tea. So objects that you would need as part of that making a cup of tea would be a cup, some tea, some water, maybe a kettle, maybe some milk, some sugar, however you like it. So those would be the objects, and then the processes would be things like boiling, as in we're boiling the water, or drinking, or brewing. All these different processes that are needed to make a cup of tea. And then the links between those objects and processes. So we could think of that if we have a teapot as an object and we have a teapot lid as an object, we might have a link to say that those two are connected. If we have a cup and we have the tea is inside the cup, again, that would be another link between those two objects. But we might have we will have links between the objects and the processes. So the object of water would go through a process of boiling where that water is moved in temperature. And how we display that is that all of our objects can have states. So if I have water, it might start with the state of room temperature and it will end at the state of 100 degrees Celsius or 80 degrees Celsius, however if you like it very hot or fully boiled. So key idea here, object-process methodology has objects and processes, and those things can be connected together, which makes it surprisingly simple and elegant, and that's very important. And Dori talks a lot in the more advanced sections of the book about why he believes that is sufficient to describe essentially everything in the universe outside of very what's beyond micro, atomic physics levels, where we have issues with uncertainty of if those subatomic particles exist or not, and things like that. But for things that you can see with a microscope, at least, and bigger, I think that object-process methodology is sufficient, as Dori explains in the book. Okay, so that was 6. What are the core building blocks of OPM? So 7. What was Professor Dov Dori's Eureka moment when he invented OPM? So in the 1990s, Professor Dori, who's a computer scientist by training, was seeing the limitations of the object-oriented paradigms that were being developed, and there were essentially standards wars and things between these different object-oriented approaches that were being used to design software systems and develop software systems. And what Professor Dori had recognized was that the object-oriented paradigm was treating objects as the first-class citizen citizen, and the methods as a second-class citizen. And to use the language that was then moved on to be developed into object process methodology, the objects are those structural pieces that likely sort of contain the data, and then within them are the methods, which were the processes. So you didn't get a process without an object. And Professor Dori, he says in 1993, was involved in a research project of digitizing what were hand-drawn engineering drawings and moving them into CAD models. And he was describing the process by which they would do this. And he identified that the processes by which these would be done should be treated as an equal to the data structures in the individual objects, and that there was this important balance that was not being used or even identified by object-oriented approaches. And so from there, Professor Dori has been able to further develop an entire syntax and used his object process methodology to develop systems and have other people develop systems, and refined it to the point now where, I mean, given that the first book came out in 2001, 2002, we've now had sort of over 2 decades of it to be out in the wild and to be used. And so it's mature, especially now we have an ISO standard. So I mentioned before that there's OPM, OPD, and OPL. What are these different things? So OPM, the object process methodology, is an MBSE approach for integrating the objects and the processes. Like, that's the fundamental framework on a single diagram. You can have multiple diagrams, but there's only one diagram type. Object process diagram, OPD, is the visual representation of that model, and the OPL is the corresponding text description. And you get both at the same time. So you don't have to say, oh, I have to create one and then I won't get the other. Essentially, most people draw their diagrams and the language is being automatically generated and updated, and they use that language to help learn and just what the diagram is actually showing, and not simply their interpretation having misremembered what the symbols mean, which can be a big challenge with SysML. Okay, so number 9. How does OPM compare to SysML, and what are the pros and cons of each? So Dori provides us a nice diagram or table, table 12.1, which is, to show you briefly, which is a comparison between between SysML and OPM. Yeah, this diagram, which essentially has 3 columns. First column being the feature, second column being SysML, third column being OPM, and then for each of them, he has described the features of each. So a key takeaway here is that SysML has 9 diagram types, OPM has 1 diagram type, and as those who are familiar with SysML diagrams, we often think of them grouped into 3 big categories of diagram types. There's the structure diagrams, there's the requirement diagram, and then there's behavior diagrams. So if the structure diagram, you've got your block definition diagram, internal block diagram, package diagram, parametric diagram, then requirement diagram, as we said, is its own separate thing. And then of the behavior diagrams, the activity diagram, sequence diagram, state machine diagram, and use case diagram. And from my experience, people do struggle to even know which diagram to start to use, in the same, there's some overlap potentially there, or at least they have in their mind some overlap, and so it can be challenging to know what to do. Whereas with OPM, you just have 1 diagram type, so you don't have to question that. You simply make new diagrams which are connected together. to add additional detail. Yeah. So, and then of number of symbols, yeah, SysML has around 120 symbols, and OPM has about 20 symbols. Yes. Oh, and interesting, it says, so logical relations, or, XOR, and SysML doesn't have a way of handling these, but OPM does. And then probability modeling, SysML doesn't have a way of handling this, but OPM does. So I think just this table alone would be very helpful for people who are trying to consider which approach to use. I would say, especially for people who don't have backgrounds in computer science or have done extensive engineering, OPM would be a much better start for, and they could use it even in domains that are highly unfamiliar with engineering. So I've taught people OPM who are musicians by background, artists by background, linguists, and they found it helpful for structuring their thoughts, where they had none such approach before. And it can also be used for rigorous engineering as well. And yeah, I've that might be a nice place to move on to sort of the next question of sort of question 10. Is OPM popular? You generally hear more talk around SysML, especially if you're in the systems engineering community. And yeah, that's true. SysML is used more, but that doesn't mean it is the better one for you and what you're doing. So the foreword was written at the front by Professor Ed Crawley at MIT, who has been using OPM in his classes from the beginning. Yeah, I mean, he actually says here in the foreword that in the year 2000, Dov Dori sort of entered Professor Crawley's office with a draft of the book, and that was he describes exactly what he was looking for the teaching of his classes, especially around the need to describe architecting and engineering of complex systems in with a solid foundation of language and methodology, and OPM has filled that gap. And I know at MIT, Professor Ollie Devek and Bruce Cameron, they both use OPM extensively in the teaching of their courses. And I myself, I've taught OPM at the University of Tokyo, in Silicon Valley, to some of the big technology companies who are using it for their software architecting, and over 6,500 students online as well. So there is certainly a large OPM community, and for the initial description of the system in a formalized way for that conceptual modeling, it doesn't have a better, or it does beat SysML with that regard. When you move into the more detail and you want to have vast number of requirements and have all of those connected to your structure, sure, maybe you do need SysML, but for the initial phase, I think OPM is a better choice for many. And as I said, it can be more easily understood by people outside of the engineering, systems, computer science domain. So question 11, what examples are described in the book? So the key example that you run through at the beginning is called automatic crash reporting. So this is you can work through it step by step with the chapters of the book. And this is all to do with a system whereby if your car was involved in a collision, it would automatically notify emergency services based on the severity of the crash as to your location, and that a crash has occurred. Because if you were to have a major accident, maybe you're not even capable of contacting emergency services. So that's the example to step through. But then there are lots of other examples. Some of them are just little ones, like a car engine. Others are more extensive. there's I mentioned the one around the frog and its life cycle, just how we put it. So it's this one, quite interesting. There's also some other biological, psychological ones. This one, figure 19.11, brain self-organized criticality maintaining in Zoom. So this is to do with the brain organizing itself, brain activity environment, sleep depriving, resetting it, all this kind of stuff. So here, Professor Dori is providing us with examples that are not engineered systems. These are biology, things that are created by nature, and they are being modeled successfully. And I know he has several papers, some on DNA, topics like this, which are very, very good at showing that it can be applied to other things. Then question 12, what is ISO 19450 and do I need to read it? So ISO standards describe the what of a thing, and in this case it's OPM, but they are explicitly not describing the rationale, so the why or the how of how to apply it. So I would say no one should go to read a ISO standard at all, really, unless they're needing to understand a particular edge case, or they are implementing a tool, for example, and they need to ensure that they cover the entirety of the language. But for someone who needs to learn and apply OPM, they'd be better off with the book, which gives them the rationale as to why things are a certain way and how they can apply it to their own projects. So question 13, what about simulation? So there are descriptions in the book regarding step-by-step state transitions, so like state machines, and how that's done in OPM, and how tools like OpCat and can do that for you, show you, and why that can be helpful for debugging and checking the flow of the behavior of a system. And I myself have combined OPM modeling, conceptual modeling, with Modelica. In my implementation, it was Daimola, which is now part of CATIA. So I was describing a system. In this case, it was some naval architecture, autonomous boats type application. And then I combined that with Modelica modeling, where I could simulate the performance of various different conceptual designs that we had created to pick one that would be most appropriate for our particular objective function. So for sure, you can do simulation combined with OPM. Okay, so final one, question 14. How can I start implementing MBSE, OPM, SysML, or otherwise? So, of course, there are many different directions to come to things. I think if you're interested in OPM, you can get one of the books. Maybe the older book if you want to go sort of purely down the OPM direction. If you've got your background in SysML or you have interest in SysML, perhaps the newer one. I myself have an online course that you can sign up to. We've had 6,500 people already who've enjoyed that course and have learned a lot of things. I think it's good to combine multiple modes of learning. Dov Dori, he's also got some courses out there which can be helpful, and you can play with the various tools as well. If you want some coaching on the topic area as well, just contact me and we can set some up. Often people have been able to make very large amounts of progress through some small tweaks to things, or setting up a detailed study plan which they can move forward on, and really make some value be created, either for their own thinking, modeling things that are more personal to them, or using it in enterprise, be it government or companies. Okay, so as I said before, I do have a spare copy of the book. If you would like to be eligible, such that I might send it out to you. You just got to do 3 things. You've got to subscribe to the YouTube channel, sign up to the mailing list, and leave a comment, and leave as many comments as you want. And come October 2024, I will pick the winner and contact them and send out the book. Thank you, and see you again soon.